Walking is something you do every day and likely don't think much about. What many people don't realize is that similar to heartbeat, walking is a cycle. How you walk, also known as your gait, is an important indicator of injury recovery and health. An irregular gait, like an irregular heartbeat, points to important present and future health issues.
Physical therapists are trained professionals in understanding gait and use it as an important tool in assessing treatment effectiveness and progress in patients with anything from a badly sprained ankle to a stroke. Yet, despite this importance, gait analysis in the majority of clinics is done entirely by the naked eye. To address this, we've developed StrideLink, a wearable device that shows meaningful metrics of a person's gait.
Our team brought together our different backgrounds in engineering with the mission to create low-cost and accessible gait analysis technology. Our proposed solution is a wearable device we call StrideLink. Our device is worn on each shoe to track a user's gait.
Because this solution is a wearable device, for the first time, gait analysis can happen anytime, anywhere, even without a physical therapist immediately involved. This solution allows for both remote monitoring and freeze gait analysis from the laboratory setting.
Here's an overview of our design. Our custom-designed printed circuit board is housed within the 3D printed casing and worn on the shoe. Now Tony and Neil will tell you more about our device.
Designing a wearable device has its own unique challenges. We wanted to prioritize making our device small and light enough so that the user doesn't even notice when they're wearing it. In order to do that, we designed a custom 4-layer PCB that is 40 millimeters by 25 millimeters. It has a removable micro SD card reader on the back and an IMU that's smaller than the size of a pencil eraser, all connected through a microcontroller with custom firmware. It also has a 7.4 volt removable battery, and the board, battery, and device weighs less than 50 grams altogether. The entire device costs less than $20.
This hardware is contained within a 3D printed housing that we made, which slots in something like this. The hooks on the device serve the role of securing the device to the shoe in a way that's still comfortable for the user to wear. Once it's secured, you can flip on the power switch, and a blue indicator LED will turn on, showing that the device is running and collecting data.
Now that we've introduced you to our physical device, we'd like to go over some details about our software. We receive the accelerometer values from the device's SD card. The device collects acceleration in the X, Y, and Z axis. You can see those accelerometer values here. That data then goes through a series of calculations and filters until we're left with the filtered data, showing the magnitude of acceleration. Finally, our gait analysis algorithm runs through the filtered data and locates strides, which indicate one complete gait cycle. Once the gait recognition algorithm is finished processing the data, the end user is able to see a clinically relevant analysis summary through the user interface. Here's a video of our device in action during our study with occupational therapist Kinsey Heron. Here you can see our gait analysis algorithm at work as we properly identify mid-stance, toe-off, swing, heel strike, and terminal mid-stance. The resulting data from the device is uploaded to our online portal. Once the data is loaded into the system, a dashboard displays familiar and important gait metrics for the physical therapist to view. The data is color-coded by foot, with blue being the left foot, green being the right foot, and black being the difference between these 2 feet as an indicator of asymmetry. The video and data you've seen so far were from our recent study with occupational therapist Kinsey Heron at Georgia Tech's Epic Lab. To validate our device, we tested it against a $40,000 research-grade gait analysis system. In order to collect and share this data with you, we received IRB approval for our protocol. Our device was shown to be within these percentages of the GateMat system. Most significantly, our device was shown to be within 0.5% of the GateMat for cycle time. With all measures being well within our goal of 5%, we can confidently say that our device is working as intended. This semester, we accomplished our goal of building and validating our device. Our next steps are to improve our device and interface. This summer, we'll be scheduling demos with PTs and biomechanics researchers to receive feedback, allowing us to further validate and begin publicizing our device. We're looking forward to seeing what kind of impact this device can have on how people recover during physical therapy and the potential role it can play in a telehealth appointment. We want to thank our mentors and classmates for their support this semester. Thanks for watching.